A powerful feature of Kinetic Model Builder is the ability to constrain model parameters using arbitrary user-defined constraint equations. The way this is done is that each model contains a list of uniquely named variables and constraint equations on those variables. And then model parameters can be set based on the variable values. So for a simple example of how to do this, we have a two-state model, closed to open, with transition rates between the two states. Now let's say, for example, that we'd like to set the opening rate to always be twice as big as or twice as fast as the closing rate. So one way to do this is simply to edit the closing rate and give it a value that is half as much as the opening rate. There we are, done. However, during model optimization, if one or both of these rates is allowed to vary, this relation will not necessarily always hold true. So we'd like to enforce it even during model optimization. To do that, we need to use variables and constraints. So let's start by adding a variable. Going into our Info tab, we bring up the tabular list of model parameters, and we go to the Variables tab. Here we can add as many variables as we'd like. For now, we just need one, so we're going to remove the ones we don't need. And let's just add a variable and give it a name x. Now, it's important that this name is unique. And we'll give it a value, how about 500? Since we're not using optimization, it doesn't matter that the bounds are incorrect at the moment. Okay, so we have a variable x with value 500. So let's set our closing rate to the value of the variable x instead of specifying the value of the rate directly. The way we can do that is simply go up here. Here's our k0 parameter, which is set to 500. Instead of 500, we'll just give it a value x. Now this must be the case-sensitive match for whatever variable name we're talking about. In our case, just lowercase x. Okay, there it is. So this closing rate now has a value of 500, or if the variable x's value changes, then the closing rate's value will also change proportionately. So now we'd like the opening rate to be twice the value of our closing rate. To do that, we simply change its value to 2 times x. Now, this will hold true no matter what value of x we have. The opening rate will always be twice as fast as the closing rate. Now during model optimization, we'd simply optimize the value of the variable x instead of the values of the rates directly. Now this equation here can take all of the traditional math operators as well as parentheses, powers and whatnot, and simple functions as well, including exponential, square root, cosine, sine. So for example, this could be 2 times x plus 2 cubed to the square root 4. This is, a bit silly, but there you go. You can do something like this or even more complicated with nested parentheses and the sort. The program used to parse these equations is EigenLab, which is available on GitHub. Okay, so let's see. The only thing we haven't discussed yet is constraints. So although it's not necessary for this simple model, let's add another variable called y and constrain that variable based on x, and then we'll use y to define the opening rate. So let's go back into our model info, and here's our variables, variable x. Let's add a second variable, and let's call it y. Right now, its value is 0. We can just leave it as such because we'll set its value in our constraints. We go to the Constraints tab. So let's say we'd like y to be twice as big as x. Y equals 2 times x. We'll do that. So every line in this constraints field is considered a separate constraint, and every part of a line following and including a pound symbol is considered a comment. So we could comment this line by simply saying something like this: set y to twice x. Great. All right, so we can close this down. So now, instead of calling this, say, as we had previously done, 2 times x, we can simply call this y. And y will always be twice the value of x based on our constraint. For further details on what model parameters can be specified in this way, please see the user's guide. But just for example, instead of K0, we could also use these sort of constraints on the enthalpic and charge components of this rate as well. Thank you very much.